Inshallah, in today's class, we are going to continue the questions based on method of variation of parameters. Those who have not seen the last part, I request first to go there and see there. Already we have done 3 to 4 questions, and there we have already understood the method how to solve the questions. Okay. Before going to the next method, I want to do one more question based on the variation of parameters. Now let me start. We know this value. We denote this by capital R. So this is e power x log x. So next thing is we know how to now y double dash is denoted by d square minus 2 y dash is denoted by d. We are taking y common into y. So this is we are having e power x log x. Now let me solve for complementary function. We take auxiliary equation. Auxiliary equation is in place of d we put m square minus 2m plus 1 equals to 0. You either factorize this one or use the calci, you will get the values of m. If you factorize this, this will become m minus 1 into m minus 1 equals to 0. So therefore, m equals to 1 comma 1. These two values are same. So we use, for these two values are same, we use, what is the formula? Case 2 for same values. We use this formula e c1 plus c2 x into e power x. Here m is 1, so 1 into x will be x. So yc equals to c1 plus c2 x into e power 1x means x. Now next step, see here, for particular equation, for no, so sorry, we are what we are doing, we are doing on questions based on parameter, change of parameters. Now multiply this c1 into e power x will be c1 e power x. Now multiply this also, you will get c2 x e power x. Now variation of parameter, what is the method? With c1 whatever we are having, you must suppose this as u e power x, and whatever with c2 you have to suppose v into, sorry, x into e. Now differentiate this one. Next step, u dash equals to d by dx of e power x will be e power x. Now v dash equals to, you see we are multiplying this two, so we have to use the method of uv. U d by dx of e, d by dx of e power x will be e power x plus v means e power x, d by dx of x is 1. Let me take common, v dash equals, if you take e power x common, you left with x plus 1. So this is the first step. Second step, we have to find w. The formula of w is u v dash minus u dash v, u v dash minus u dash v. So equals to, u is e power x into v dash, v dash is e power x into x plus 1, u v dash plus, sorry, minus u dash, u dash is e power x into v, v is x into e power x. You see here, e power x into e power x will be e power 2x. So let me take common e power 2x from both. E power x into e power x will be x plus x 2x. E power x into e power x 2x. If you take common, what is left here? Here it is left with x plus 1 minus here is left with where x will get cancelled. Therefore, w equals to e power 2x. W equals to e power 2x. So we got the next step also. Now we have to find a and b. We have to find a and b. So what is the formula of a? A equals to minus integration of v into r by w, minus integration v. The value of v here we are having x into e power x into r. In the first step we have denoted r. R is e power x log x divided by w. W, the value of w is e power 2x. E power 2x. Here, whatever the right hand side, this we denote this by r. This is denoted by r. So we use here minus v into r by e. You see here, e power x into e power x will be e power 2x. E power 2x, e power 2x get cancelled. Now, how to solve x into log x? This is multiplication and product rule we say in integrations. In integrations, there is a method of product rules. For that, the order should be ILATE, I-L-A-T-E. So first we must get log, then x is algebra. X is algebra. So first you change the order. You write first log x, then x. This is the method. No? Minus of integration of, first you write log x, then x, then dx. Because multiplication For integration, we use integration by parts. For integration by parts, we use the order as ILAT. L means log, so should be first, then x should be second. Now when we multiply these two, we have to use integration by parts method. F of x into g of x dx equals to f of x integration of g of x dx. This is the formula, minus whole integration d by dx of f of x integration of g of x dx whole dx. You see, those who don't know this formulas, you revise this. This is the basics of f of x into g of x is f of x integration of g of x dx minus whole integration d by dx of f of x integration of g of x dx whole dx. Now let me use this formula. You see here we are having minus, so you take minus bracket. F of x is this, g of x is this. What is the formula? F of x means log x integration of g of x integration of x dx minus whole integration d by dx of f of x. F of x is log x into integration of g of x. G of x is x dx whole dx. Now let me continue, minus of, you see here we are having log x as it is. You write log x. Now integration of x power n is x power n plus 1 by n plus 1. So x power 1 will be x power 1 plus 1 to x square by 2 minus whole integration d by dx of log x is 1 by x. D by dx of log x is 1 by x. Integration of x is x square by 2 whole dx. You see here this x and x square will get cancelled. Now what is left here? Here it is again, you left with x. So integration of x will be x square by 2 by 2 by 4. It will become x square by 4. See here, I'm adding one more step here. See here, minus of, I'm writing first this x. So see what, let me do one thing. Let me start from the starting of the board. See here, let me continue what we have done. Now let me see this x square get cancelled. Again we left with x. If we again integrate x, x will be x square by 2. Integration of x is x square by 2. Again 2 means already 2 is there, 2 to the 4. So we get like this, minus of, you write this first, x square by 2 log x minus integration of x, again x square by 2 by 2 by 2 by 4, x square by 4. Let you do one thing. Let me take common here. If you take, let me multiply with minus and take common x square by 2. If we take x square by 2 common here, 2 is left in the denominator. Because we have taken minus common, this will become plus 1 by 2. X square by 2 taken common and we multiply with minus, this will be minus of log x. Minus of log x. So we got the value of a. This is the value of a. Now let me find b. The formula of b is integration of u into r by w equals to integration of u. What is the value of u? The value of u is e power x into r. The value of r is e power x log x divided by w. The value of w is e power 2x dx. This e power x plus x to x. E power 2x, e power 2x will get cancelled. So b equals to, what is left here? Integration of log x dx. You do one thing. You by heart integration of log x. Generally we use log x comes mostly in the questions. So integration of log x is x into log x minus 1. Integration of log x is x into log x minus 1. Better you by heart the integration of log x, x into log x minus 1. Therefore, we know particular integral is y equals to, what is the particular integral? Y equals to a into u plus b into v. So y equals to a into, just now we got the value of a here. This is x square by 2 into 1 by 2 minus log x into u. The value of u is e power x plus b. We got this way here, x into log x minus 1, x into log x minus 1 into v. The value of v is x into e power x, x into e power x. Even we can solve by taking common in this 2, or else we can leave here itself. Okay, if you want to solve, let me do one thing. Y equals to, see, x square, x into x, x square. Let me take common x square, then e power x, we take x, e power x common. So if we take x square and e power x common, x square and e power x common, what is left here? 1 by 2 into 1 by 2 minus log x. Multiply this 1 by 2 into 1 by 2, 1 by 4 minus 1 by 2 log x, plus we have taken x square and e power x common. So what is left here? We left with log x minus 1. Log x minus 1. Let me solve this 2-3 steps. Let me take LCM. So this is particular integral that we denote by yp. So yp equals to x square e power x. If you take LCM, you will get 4. So what left here? 4, 4 same. This is 1. 2 2s are 2, 1s are 2. 2 log x plus 4 into log x. 4 log x. 4 into log x is 4 log x minus 4 ones are 4. So let me make this last term. So yp equals to x square e power x by 4. I'm writing like this. Now you see here 4 log x minus 2 log x will be 2 log x. 1 minus 4 will be minus 3. So this is the particular integral. Now the last step there for complete solution. For complete solution, what we did do, we write particular integral plus complementary function. Therefore complete solution is y equals to yc plus yp. Y equals to yc, we already got previously, c1 plus c2x into e power x, plus yp is here x square e power x by 4 into 2 log x minus 3. 2 log x minus 3. So this is the one more question we have done this. The special thing in this question is, what I want to show is, when we multiply two functions, we have to use product rule, integration of f of x into g of x. F of x integration of g of x dx minus whole integration d by dx of f of x integration of g of x dx whole dx. This is called integration by parts. If you want to go in detail in that type of questions, you go in my playlist where inter second year questions are there. Integrations, inter second year questions, there can have few questions on this formulas. If you want to have perfection over that, you go through there that questions and practice it. It's a very small topic here. You see here linearly dependent functions. When we call, suppose we are having three functions, y1 y2 y3. We are having three functions, y1 y2 y3. If y1 y2 y3 y1 dash y2 dash y3 dash y1 double dash y2 double dash y3 double dash determinant is 0, then we say these are linearly dependent. Linearly dependent function if its determinant is 0. If its determinant is 0. Also, if the determinant is not equals to 0, we say that the functions are linearly independent. Equals to 0, dependent. Functions are linearly dependent. That is, we have to find y dash, y double dash, similarly y2 dash, y double dash, y3 dash, y double 3 double dash, and let me find the determinant. If the value is 0, we say linearly dependent. If the value is not 0, we say linearly independent. So let me do few questions based on this. So let me continue here. Show that the functions f1 of x equals to x square, f2 of x equals to x cube, f3 of x equals to 6x square minus x cube are linearly dependent. Also find a relation between them. Let me see the relation afterwards. First we have to differentiate each functions 2 times. Let me differentiate f1 dash of x. We know d by dx of x square is 2x. Differentiate one more time, f1 double dash of x. D by dx of x is 1. 1 into 2 is 2. Similarly come here, f2 dash of x. First time differentiation, x cube, we know differentiation of x cube is 3x square. Again f2 double dash of x, differentiation of x square is 2x, so 2 3s it will be 6x. Now come here, differentiate first time, f3 dash of x equals to d by dx of x square is 2x, 2 6 are 12x minus x cube is 3x square. Differentiate one more time, f3 double dash of x, x will be 12 is x, d by dx of x is 1 into 12 is 12, x square is 2x, so this is 6x. Now we have to find the determinant of this. We have to find the determinant. f1 of x, f2 of x, f3 of x, f1 dash of x, f2 double dash of x, sorry, f2 dash of x, f3 dash of x. In the same way, second differentiation, f1 double dash x, f2 double dash x, f3 double dash x. Now let it find its value. If its value is 0, we say dependent, and if its value is not equals to 0, we say independent. So let me substitute the values. So what will be the values here? Watch here. f1 of x is 2x, f2 of x is x cube. Here it is 12x minus 3x square. Now next is dash. Here is, sorry, f of x is x square, so this is x square, x cube, 6. Now here 2x, and here is 3x square. Here is 12x minus 3x square. I think I am doing some mistake here. Yeah, here also we done mistake. What is here? 6x square minus x cube. This is 3. So lastly here you get the value 2, 6x, 12 minus 6x. So see here once more. The first step, this is the first step, this is the second, this is the third. Let me do one thing. We can take common x from here, x square from here, and x from here. Let me take common. If we take common, the numbers will become easier. See here, in the first row, x square, x cube. Here also x square, you can take common x square. In the second step, you see here x square, here also x. Let me take common x. And in the third, we can take two commons. So I'm taking commons first to make the question easier. We can take common. So if you take common x square, you left with 1. If you take x square common from x cube, we left with x. We have taken x square common, so it is left with 6x minus, sorry, 6 minus x square. 6 minus x square. See here, 6 minus x square, because 6 minus x, we have taken x square common. Now from here we have taken common x, so it is left with 2. Here it is left with 3x. Here it is 12 minus 3x. 12 minus 3x. Now here also let me see the last one. We have taken 2 common, so here left with 1. Here we have left with 3x. We have taken common, so it is left with 6 minus 3x. So just you revise, we have taken common x square from the first, so x is 6 minus x. Here also x we have taken common 2, 3x, 12 minus 3x. Here we have taken common 2, so it is 1, 3x. See here, let we take still common. We can directly solve, or if you want, we can change more easier. You see here, 2 into x square into x will be x cube. X square into x is x cube. I'm doing one more thing. Let me take common still. You see here, I'm doing this 2 also 0. Watch carefully. I'm changing like this. R2 implies R2 minus 3R1. Or else let me multiply and make 0. Let me make few zeros. If we multiply 3 into x, 3x minus 3x will become 0. So R2 implies R2 minus 3R1. R2 implies R2 minus 3R1. Why we are making 3x will 0, this value will become 0. In the same way, R3 implies R3 minus R2. 3 minus 3 will be 0. So what is left here? 2x square into x, 2x cube. Now you write the first one as it is. Now watch carefully. R2 minus 3R1. R2 minus 3R1. 3 ones are 3. 2 minus 3 will become minus 1. R2 minus 3R1. 3 into x, 3x. 3x minus 3x will become 0. R2 is 12 minus 3x. R2 minus 3R1 means minus into plus, minus 3, 6 is 18. Minus 1 is plus 3x. So plus 3x minus 3 get cancelled. What is left here? Minus 18 plus 12 will be minus 6. See here, R2 minus 3R1. R2 is 12 minus 6. Minus 3R means minus 3, 6 are 18, minus 2 minus plus 3x. So 12 minus 18 is minus 6. This will get cancelled. So lastly, this one, 1 minus 2 minus 1. 3x minus 3x, 0. If you minus this here, R3 is 6 minus 3x. R3 is 6 minus 3x. Minus R2 means minus 12 minus 1 is plus 3x. Plus minus cancel. What is left here? Minus 6. No, watch here. No need to solve extra because these two rows are same, minus 1 0 minus 6 minus 1 0 minus 6. Even if we expand also we'll get 0, but we are having the fundamentals and principles of determinants that if two rows are equal, then its determinant becomes 0. So this will be 2x cube into 0, so 0 into a number 0. Therefore the functions are linearly dependent. The functions are linearly dependent because these two rows are equal. Therefore the determinant value will be 0. Even if you solve, this will become 0 itself. If you solve, you will get minus 6 minus 1 plus 6 becomes 0. So determinant is 0. Now let me do one thing. Also the question is written to find the relation between them. So you see here, let me write a relation very easy here. Watch carefully. What we are having, we are having f1 as x square, f2 as x cube, and f3 as, I'm writing f3 here. F3 of x, we are having 6x square minus x cube. F3 of x equals to 6 into x square. X square is f1 of x minus x cube is f2 of x. So this we call the relation between f1, f2 and f3. Relation between f1, f2 and f3. Now see the next question. Show that the functions x, x square, x cube are linearly independent. Let me do a thing. Let me start that the first function is denoted by y1, the second function by y2, and the third function by y3 equals to x cube. Now we have to differentiate two times. Y1 dash dy dx of x is 1. Again, if you differentiate, constant differentiation is 0. X square differentiation is 2x. Again, if you differentiate, x is 1 into 2, 2. X cube differentiation is 3x square. If you again differentiate, it is 6x. Now we have to find the determinant. Just now we have seen the question is so easy. I'm explaining short. Y1, y2, y3 dash, all let me substitute these values. After substituting this, let me solve this one. One way is taking common, but this question is so easy. Let me just start directly. Let me expand this one. Okay. So when we take x, we already know from matrices, when we take x, we multiply this 2 minus this 2. We multiply this 2. 2 6 12, x into x, x square. 12x square minus 2 3 6x square. Whenever we take x, we multiply this 2 minus this 2. 12x square minus 6. We have to take negative sign of this, minus x square. Now use this one, multiply 1 into 6x, 6x, minus 0 into a number will be 0. Now lastly x cube. If you take x cube, we have to leave this column. Leave this column. To multiply 0 into 1 into 2 is 2. 2 minus 0 will be 2 only. So what is left here is here. 12 minus 6 is 6. 6 in x square into x, 6x cube. Once more is here. 12 minus 6 is 6. 6x square into x is 6x cube. Minus 6x cube plus 2x cube. This minus and plus will get cancelled. 2x cube. That is, determinant is not equals to 0. Therefore, we say that the functions are linearly independent. The functions are linearly independent. So in this class, actually, we have seen the variation of parameters, very important topic. And the second topic is linearly dependent and independent. For few universities, this portion is there in the book, and for few universities there is no portion. This is not in the syllabus. So you better see, if you have the syllabus, you practice. Otherwise, you leave this one. So let me continue in the next class with Cauchy's homogeneous equation, very important method. Inshallah, we are going to continue in the next class section.